Hi everyone. So today we want to study regression by basis functions. So remember that last time that we used the polynomial regression and also the step functions for regression. So today that we want to generalize that idea to use general function of x, b1x to bkx to regress y. So remember last time that we used Nile River water level data. So that is the data from 1871 to 1970. And the Nile is the water level. This is default dataset in R. So we have this scatter plot. So we want to fit a curve on this scatter plot. So today I want to use cosine curves and sine curves to regress this Nile River data. So first variable C1 is the function of time, and we just shift time by 1870 to avoid the numerical overflow, and times 2 pi divided by 200. So basically this is just the 0.5 period for 100 years. So cosine curve. And if we define the sine curve in the same way, if we combine these two, then we can shift the graphs to the right or left, horizontally, and also we can magnify the graph. So it's somewhat flexible. But only two curves, still that we can only fit the sine curve or cosine curve. So we prepare cosine curve with higher frequency. So actually this is the one period is 100 for this C2 cosine curve. And also we define the sine curve with the same frequency. So we want to use these four curves to fit Nile River data. So just to show how these curves look like, I just adjust the level and also adjust the magnitude of these variables, and we want to at first see what curves we are using. And these are the curves. So the black one is the cosine curve with lower frequency. So the period is 200. And red curve is sine curve with lower frequency. And the green curve is cosine curve with higher frequency. So frequency is twice as large as black one. And the blue one, actually the sine curve with higher frequency. So we use these four curves to fit this data. So this is just linear regression. So we can regress Nile on C1, S1, C2, and S2. You can see, for example, summary of LB2. Then you can see actually C1 and C2 are useful, and S1 and S2 are not really significant, but it makes sense to use as a pair, C1 and S1 and C2 and S2. So now that we plot and we overlay the fitted line, so we have already have four curves here. So we put the fitted line maybe with another color 5, maybe slightly thicker one. Okay, so now the light blue curve, so this is fitted curve. So it's higher in the beginning and it gets lower around here and it stabilizes around here. So this kind of curve is good to fit some periodic function y. So this is not very periodic, so I'm not sure if it's the best way to fit the data. But in this way, we can flexibly use the linear regression. Okay. So this is basically basis functions. We can also calculate the AIC. So AIC of this model is 1274. So this is comparable to polynomial regression, and also this curve that doesn't blow up when x time is out of the range. So somewhat this is better than polynomial regression. Okay, so see you then.